Thanks for having me. Excited to be here. This is an awesome event. I was walking down around kind of like all the booths and setups downstairs, and there's some awesome companies and some awesome technology here. And I think part of the excitement that we feel every day at LangChain is it's just an awesome time to be building. And I think I hope all of you take a minute among the frenzied releases from OpenAI and everything like that to appreciate how fun it is to be building in today's environment. Big thanks for having me. What I'm going to be talking about is building context-aware reasoning applications with LangChain. And so that's a bit of a mouthful, but I'm going to walk through what exactly that means, how we think about that internally, and then talk about some of the issues and problems that we currently see facing builders. And so, it kind of starts with ChatGPT, which took the world by storm, leveraging, these large language models, which can do amazing things. And when LangChain was getting started, it was actually before ChatGPT was released, but it was after there was like the Text DaVinci 2 models that were out. And so people were playing with them and using them. And a lot of what we observed was they weren't just using them to simply call the language model, because that wouldn't power kind of like distinctive and personalized and engaging interactions. It wouldn't know kind of like, what the weather is today in San Francisco. It wouldn't know about your data. It wouldn't be able to connect to the real world. And so a lot of what we saw people doing was connecting these language models to other sources of data and other sources of computation, and really building what we now call kind of like these context-aware reasoning applications. And so a few of them are kind of like highlighted here. And the things that they have in common are that they're about a lot of it's about bringing the right context to the language model and then asking the language model to reason over that. And I think those two things are both really important for driving these new distinctive types of applications. If you don't bring the correct context, it's not going to provide the correct answers. If you don't bring distinctive context, it's not going to be differentiated from a competitor down the street. And then the new thing at the end of the day are these language models. And one of the big unlocks that these provide is some sort of reasoning ability, and we can argue about whether that's actually reasoning or not, but it definitely approximates that. And so a lot of the applications that we see being built, whether it's connecting to your tables in Spark or whether it's building different characters, are about bringing relevant context and then reasoning over it. And so I want to break down what those two things are and talk a little bit about how we see companies doing both of those. So on the context-aware part, there's kind of 4 different types of context that we see people bringing in to their applications. And importantly, these are 4 different types. They're not 4 different levels. They can be used together and in combination, and most often we see people using these in combination. The first is a really simple type of context, which is just instruction prompting, bringing instructions to the language model. And this is really basic, but I would argue it is a form of context, because we often see people encoding how they want the language model to respond according to their beliefs about what a good response should be, about what their company's policies are, about how to handle certain scenarios. The way that we think about this is kind of like giving a new employee handbook on the first day someone shows up to work. You're telling them how to do things, and that's providing relevant context on how they should be doing things. The next type of context is a level up, and so rather than telling the language model how to do something, you show them some examples of how to do something. And this is done through few-shot examples. And so what this does is you provide a few example inputs and example outputs, and then you ask the language model, usually along with some instructions, to basically do the task. And this helps over instruction prompting when it's tough to convey in instructions what exactly you want the language model to do. So this helps a lot with kind of like output formatting. If you give some examples of the correct output, that can lead it in that way. Another place where we saw this being really helpful is when trying to instruct a language model to respond in a specific tone. If I try to talk about my tone, it's kind of difficult to describe someone what my tone is, but if I show them 10 examples, it becomes a lot easier for them to get a sense of what my tone is like. And so we see them being used in this way, and we also see there being different ways to select these examples. So the naive thing to do is take 3 or 4 examples and just put them all in the prompt, and you've got them there. The next level up from there is have a database of 10, 20, 50, 100 examples, and you select the 3 or 5 most relevant for the input, and then you put those in the prompt. And so it dynamically kind of changes the prompt each time. And that's really useful, especially when you're doing things like generating SQL queries, where you could have one SQL query example that's just like not at all relevant to the question that's coming in. And so if you instead select 3 from 100, you're more likely to get relevant queries, and it's more likely to be helpful. The next type of context is probably what people most think of when they think of context-aware or using LLMs with context, and it's this idea of RAG, or retrieval augmented generation. And here you're using the context in a different sense. You're not necessarily using it to tell the language model how to respond, but you're using it to say that this is the information that it should base its response on. So the classic example of this is you might be doing question answering over some PDF, and so you have some prompt templates that's like, here's the user question, respond based on the following context. And then you select the relevant 2 or 3 paragraphs from the PDF, put it in the prompt, and pass it to the language model. And so then you're asking the language model to respond not on the knowledge that's intrinsically in its weight or not on how it was trained, but instead on this context that's been pulled into the context window, into the prompt. And this doesn't have to be kind of like traditional retrieval either. This can be calling APIs, calling structured data to get the relevant data. The main thing here is you're just grounding the language model in this context. And then the fourth type of context that we see people starting to do more and more nowadays is fine-tuning. And so this is actually, I would argue that this is bringing context to the language model in the form of updating its weights. And again, we see this being really good when it's tough to give specific examples for how the language model should perform, and when you need a lot of examples to really convey that. So in the previous example around tone, sure, I could give it 3 or 4 or 5 examples, but if I could give it like 1,000 examples of my type of tone and fine-tune a language model over that, it's going to have way more context to know what my tone actually is. And so tone and structured data response, responding in a structured format, those are kind of like 2 of the main ways that we see fine-tuning being used to provide some context. Next, I want to talk about reasoning and how to get the language model to take this context and respond appropriately. And so I'll define this as kind of like you've got some input from a user and you've got some output, and what's going on inside this box, where the language model is one component, but what else is in this box? How is the language model interacting? And so here, we've started thinking about this, and this is by no means kind of like a perfect categorization, and I'd very, very, very much welcome kind of like feedback and thoughts on this. But we see a few different levels of reasoning kind of progressing from simplest to kind of like most complex. And so walking through them, the first is kind of just a single language model call. So you've got this box, and all that's going on in this box is you're passing it to a language model, getting the output, and you're passing that output directly to the user. And so you've maybe got you've got the context retrieval going on maybe, but there's not too much kind of more than that. It's passing it to a language model and doing that. And this is this is not like a bad level of reasoning. And so, despite there being levels of reasoning, it's not like any are better than another. So one of the big benefits of this is that this is really, really fast compared to other of the cognitive architectures that we'll talk about. This is just a single language model call. And so a lot of the question answering things that we see doing this, like Perplexity, are probably making just a single LLM call, and they're responding really, really fast, because in chat, like this speed is really, really important. And so you've got this cognitive architecture, which is relatively simple, but gives you that speed to respond quickly. Taking it up kind of like to the next level, we see basically multiple LLM calls or multiple calls to kind of like different services orchestrated in kind of like a pipeline. And so thinking about that chatbot example, it works well to do a single LLM call the first time, but when you're having a conversation, a lot of folks actually do 2 LLM calls. And what they do is they take the language model, and then they take the conversation and the new question, and then they use that to generate a query to look up something in a vector database, and then they get that context, and they put it back in, and they make a second call. And that's needed because basically if you just pass the conversation to the embedding model, because it's in the conversational style, it might not be clear what exactly you need to look up. And so there's this idea of chaining language model calls either together or with other services that you can call. And so as an example of this is GPT Researcher. Just to make this a bit more concrete, this is an awesome open source project that you guys should all check out. it writes a final report, and basically you can see that there's this chain of things that are going on. You've got a task that comes in, you generate a bunch of research questions, you then split them up, you do some queries on them, you get the summaries from researching those on the internet, you then pass those to a report agent at the end. A report agent is just a single LLM call, and so it writes a final report. And so you've got this pretty complex flow that's going on, and it's this sequence of steps. Importantly, in chaining, the sequences are pretty well defined. So you do this, and then you do this, and then you do this, and then you do this. And it's kind of known what the steps are. The next level that we see is when you start using a language model to control what the steps actually are. So should I take this step, or should I do this step? And this can be used to route between different prompts. This is a great, this is maybe one of the more common ones. So based on the user input, should I use this prompt to respond that says, you're a great mathematician, solve this math problem, or should I use this other prompt to respond that says, you're Shakespeare, write a poem? It might depend on the user question. And so having that route between different prompts, having that route between different models. So if we know that some models are better than others, this is maybe not necessarily using a language model. We see people using heuristics to encode this kind of like routing. And then another good example of this is determining what to look something up in. So if I have a retrieval-based chatbot, do I want to look up things on the internet, or do I want to look things up in my private vector store? You can use a language model to determine not only what the search query to those should be, but actually which one to use. And so going back to the previous example, I actually lied to you a little bit, and there's actually some routing going on. And so the final report agent is parameterized by a prompt, which depends based on the input. And so the input's passed to a prompt that's then asked to choose one of several kind of like final agents to use to generate this report. There's one for scientific stuff. There's one for just more general web research. Importantly in here, we haven't got to this idea of any loops yet. And that's kind of like the next level up, where we see these loops start to enter this picture. And you start having these automatons or state machine type things. And so to make this really concrete, and so this is actually the area where we see these things start to becoming called agents. So agents is a bit of an overloaded term, and this is part of the motivation for trying to think really carefully about what the levels of reasoning are. But this is where we start to see a lot of things start to be called agents. And this is also where a lot of the applications that are actually used in production actually stand. And so taking a look at kind of like a few examples out there, this is from Baby AGI, which is another awesome open source project. And it's also very similar to a plan and solve paper. And so we implemented it in LangChain as a plan and execute agent/automaton. And so you can see here, there's 3 different agents going on, and there's these different transition states that you can go to from steps. And so you've got this loop where basically the user will pass in kind of like an objective and a task, and it then generates a bunch of subtasks. It then goes, executes one, it comes back, updates its to-do list, and kind of like continues accordingly. And so there's this predefined kind of like, there's this transition matrix between these different states, very similar to this kind of Reflexion paper that we have here, which is an improvement upon React. And you can basically see in the agent box, there's 3 different kind of like boxes for LLM calls, all of which are basically LLMs parameterized by prompts. And you can see all of them have kind of like different objectives. So one's kind of like evaluating itself, one's doing some self-reflection to update the experience, and then the other is actually determining what steps to take. And grounding this in a really concrete example, here's sweep.dev, which is another awesome open source project, this time for code generation. And they published a great blog about the internals of their architecture. And there's very much kind of like this transition matrix going on, where you can see that based on the inputs, they first do a search, and then they go into this plan, execute, and validate loop. And at some point, the validation step says, yep, you're good, and it kind of like finishes and submits a PR or returns to the user. And this is one of the really common types of cycles we see, is basically this plan, execute, validate loop going in circles. If we think about the next level up, which is this idea of autonomous agents, it's a little bit like this is kind of like missing something from the previous one, and the thing that it's missing is these explicit states that transition between kind of like planning and executing, or reflection and acting, or executing and validating. And so really what you're doing is you're asking the language model to transition between those states implicitly as it's being called. And so it's putting more burden on the language model to know when it should be thinking about what to do versus like validating what to do. Is it able to do it in one shot versus like, is this try validate thing actually valuable? And so this is very tantalizing from the idea of if we get here, we can have this like autonomous system where you just kind of like give it tools and ask it reason about what to do. In practice, again, we see most of the agents being deployed in production have more structure on how they transition from state to state, rather than just rely on the language model itself to determine what to do next and then when to end. And so this is a new diagram that we've kind of tried to put together to try to just like codify some of this thinking, and we've tried to basically say like what is doing things? Is the human with the code doing things, or is the language model doing things? And so up on top, if it's code, the human and code is doing everything. Then you start using an LLM call and chains, and there like the outputs are determined by the language model. Then determining what steps to do. That's when you get into routing and state machine type things. And then defining the state transitions. Honestly, we might need to work on this column a little bit, but the idea is that you're relying on the language model to do these state transitions implicitly rather than having them codified in this kind of transition matrix. So that's a little bit about how we think about kind of like context-aware and reasoning at LangChain. And now I want to talk a little bit about some of the difficulties that we see. We see a lot of Twitter demos where people are popping up with all these prototypes, but we see very few of them, or at least a much smaller number of them, making their way to production. And I think there are a good amount of difficulties bridging these two worlds. And so I want to spend the rest of the time talking about that. The first difficulty, and the main thing that LangChain was built around, is the orchestration of all of this. So what are the different chains that you might want to try? What are the different routing techniques? What are these different kind of like cognitive architectures that you might want to try out? And so LangChain, for those of you who don't know, is an open source framework for building LLM applications. There's kind of two main value props. One of them is a bunch of different modules where we integrate with a bunch of different language models and vector stores and tools. And then the second value prop is a lot of these end-to-end chains or end-to-end agents, where it makes it really easy to get started with kind of like question answering, chatbot question answering over SQL databases, agents that have access to tools. And we have a bunch of these different cognitive architectures in the package, making it easy to basically pick up any of these ways of doing orchestration and try them out. So I think there's three largest difficulties in terms of getting started. The orchestration bit, that's kind of like one of the main value props of LangChain. The next two things are the things that we see the most people who are people who are using LangChain spend the most time on. And so one of them is just data engineering. And so a big part of this is providing the right context to language models in the right places. And so you need to hook into those stores of that right context. You need to transform the context correctly so that it appears nice to the language model. And that's just some good old-fashioned data engineering. And so we see a lot of people spending time on doing that. And then the second thing where we see a lot of people spending time is around prompt engineering. At the end of the day, the new thing here is the language models, and the way that you interact with the language models is through prompts. And so we see a lot of people spending time on what exactly the instruction set is, what are the examples it's providing, and then also on prompt construction, which I would basically just say is the way of organizing. You've got instructions here, then examples here, then your context you want to ground it in here, and basically combining that all together. This is all made difficult as the applications kind of like scale, because you've got these different pieces, and as you start to scale up the complexity, you've got a lot of these different pieces kind of like that need to coordinate with each other, and you've got this orchestration flow. And so all the screenshots that I'm showing are from LangSmith, which is our platform for kind of like debugging, logging, testing. I'll talk about that later on, but the main value prop that we see it being used for is just debugging of all these things. So what exactly is the orchestration that's happening in my cognitive architecture? So on the first slide, you can kind of like see the exact steps that it's going through. And you can see kind of like what's going on, the language model that's being used, the tools that are being used, and have that visibility into what's going on. You can see the exact inputs and outputs of each step. So what data is flowing through the system. If you don't have the right data and if it's not formatted the right way, the language model is not going to know what to do. And so just having that sanity check of what's going in and what's going out of the language model is really impactful. And then prompt engineering as well. Again, if you have these complex applications, you've probably got multiple prompts that are being called either in sequence or at various points, and so knowing which ones are called and then being able to jump exactly to the point that it was called and see like what exactly the prompt is, what exactly the prompt responds with, and being able to play around with that is really important for this debugging cycle. So we've made it easy to basically go to a step in your chain and then click into it and onto a playground where you have the prompt that was at that step in the chain. You can play around with the parameters. You can play around with the template. You can switch up the language model and basically debug a lot of these issues. One of the bigger open areas of research and just time spent and questioning, I would say, among the companies that we talk with is how to evaluate these things. And so these things are pretty difficult to evaluate for a few reasons. Two of the main ones being a lack of data and a lack of metrics. So unlike in traditional machine learning and data science, when you start building a lot of these applications, you don't necessarily start with a data set. So you had to do that in data science because you had to train your model. Nowadays, these language models are fantastic zero-shot learners, and so you can start with an idea of what you want to do. You can play around with the prompts, and you can get something working, which is great because you can get something working really fast. But then when it comes time to actually have any semblance of benchmarking or seeing how you're doing, you don't have this data set that you maybe normally would have built up in traditional machine learning or data science. And so we see people trying to gather this data set in a few ways. One is good old-fashioned kind of like human labeling. That's the most kind of like trustworthy. This can actually be done in a few different ways itself. So you can either just generate kind of like inputs and expected outputs on the fly, or you can look at your kind of like production traffic and logs and see what people are actually asking questions of, and then use those as kind of like your data set. That's kind of like the way that we've preferred to do things when we've been benchmarking. Because part of the difficulty is we don't know exactly how people will be using our application until we put it out there. And so adding in this level of basically looking to see what questions people are actually asking, then using those as data points is helpful there. Another way to generate data points is through using LLMs to generate synthetic data. So you ask it to generate a bunch of inputs and expected outputs, and you can quickly bootstrap a data set. That may not be perfect, but is easy for bootstrapping that way. On the metrics side, a lot of the traditional ML and data science metrics no longer apply super well here. If you're working with a task where you're doing classification, or if you're doing NER, then maybe you're lucky and some of those metrics do apply. But a lot of the outputs of these systems are kind of like generated text. And so it's really tough to judge how well that generated text is. Some of the ways that we see people doing this, again, human labeling, so having people look at the answers, and then using LLMs to evaluate the outputs is another thing that we see people doing. Again, it's not perfect, but we're pretty bullish on that as an approach in the long run to getting at least some idea of like where to look. So far what I've talked about is mostly kind of like offline evaluation. There's also this idea of online evaluation. So after your system is in production, how do I know what's going on? Really basic, but the main important thing to do here is start collecting feedback, either explicit or implicit. So explicit would be adding like a thumbs up, thumbs down button to your chatbot, and then looking at the percentage of thumbs up, thumbs down that users give it. You can use that to then identify like problematic data points or just track the performance over time. Implicit might be like, if they asked a follow-up question that's really similar, then my response is probably not that good. Or if they clicked on a link, then my response was pretty good. And so you can kind of like look at their actions, even if they're not giving you feedback directly, and use that as a way to track performance over time. The last thing that we're thinking a bunch about is around the collaboration aspect of all of this. So again, as these systems start to get bigger and bigger, you've got multiple teams and multiple people collaborating on these. And so one of the interesting things that we've noticed here is this collaboration isn't just among kind of like technical teams and technical people, but a lot of the prompt engineering in particular is actually maybe best done by a project manager or someone with subject matter expertise who may not be technical and may not be comfortable living in code or living in GitHub. And so we're thinking that it definitely starts with the prompts, and we want to make it really easy for anyone to kind of like play with prompts, evaluate prompts eventually, and kind of like edit those prompts. At the same time, we think there is a huge kind of like, we think there needs to be a lot of kind of like engineers involved. Like a lot of this is around bringing the right context, which is a lot of data engineering and orchestration of all these systems and connecting. And so we don't think it's purely kind of like a low code, no code play either. I think there's this really interesting intersection of prompt engineering versus data engineering and figuring out the right way to marry those two. I think is going to be pretty important in the long run. We've taken kind of like an initial stab at it with kind of like Prompt Hub and Prompt Playground, where you can share and explore prompts as well as edit them, version them, soon fork and add comments on them. But I think there's still a really, really long way to go here. That, I think, is it. Thank you guys for having me. Really excited to be here.